starting with a simple masonry concrete masonry box. It could be either brick, it could be block. In this case, we're using 8-inch block. We're not using any mortar because this is going to be disassembled. This is the prototype. But when you folks build it, you're going to be using mortar for your head joints and the bed joints. Your inside dimension, whether you use brick, whether you use 8-inch block, whether you use 6-inch block, it doesn't matter. You want to have an inside dimension of 24 inches in width and 48 inches in length. You want to make sure it's square, you want to make sure it's laid on a level pad, and you want to make sure that it's level, the masonry, as you lay it up. That's critical. Simple way to do it would be using diagonal square to come up with a consistent number. Once it's a consistent number both ways, then you know that you have it square. At that point, that first course is in. Whether it's brick or block, it doesn't matter. The inside dimension, as we said, has to be 2 foot by 48 inches. And that bonds out with brick or block. No cutting necessary. The only cut necessary, as you can see here, is I hogged off the ears of 2 of these 8-inch blocks for a specific reason. One is so that we can set the burner in there, and the other remaining portion that's cut out is so that it gets air intake into the firebox to be able to work. So after you lay your first course, this assembly, which is the burner, will be set into the first course. You don't have to worry about or be scared of this burner because I'm going to make them up and we're going to send them over. All you have to do is know to put this one joint together at the T. When I send it, these are all going to be packaged together. This one joint just has to be put together. No adhesive or Teflon tape necessary. A pipe wrench and a vise or some way of holding this so this can be torqued on tight is all that's necessary. The burner is then laid in place. Center inside the firebox. Remember, if the center is 2 feet, the center is 1 foot. And again, 1 foot. And again, the center of the box this way is where we've hogged off the ears. That's why the first course, if you're laying in block, has to be laid in this fashion so that you can chop off the ears and have that hole. Now that our burner's in place, we can go for the second course before we set our metal plate. Second course, the block. Again, I can't emphasize enough that you need to make sure it's level, plummet your corners, and remain square. At this point, for our purpose here on the prototype, I made notches in the top of the block in the second course to allow our rebar to bridge across. Randomly, no specific measurement. 3 rebars is all you're going to need for the steel that you're going to have in order to support it, which you'll see coming up. In your case, you can lay the rebar right into the bed joint of the third course, which would be perfectly fine as long as you maintain that 1/2-inch bed joint on the ends as well, again, to remain level. So at this point, we have our rebar installed. At this point, we have a piece of 3/16 flat steel, non-galvanized, that we're going to lay across our rebar bridging. Now, this part is critical so that the oven operates correctly, is that we need equal air spaces at each end of this steel. So Jose, grab that end, and let's slightly move it towards you. All right, let me check and see what I got. I've got 3.5 inches on this end, and I've got 3.5 inches on this end. The plate is now set. Remember, it's 3/16 non-painted steel. You can go up as high as 1/4 inch if you need to. But the dimension of this to fit this box, as we said earlier for the inside dimensions, is 40 inches by 2 feet. 40 inches by 2 feet, 3/16 rolled steel, non-painted, non-galvanized. And like I said, you can go up as far as 1/4 inch. Cut. Okay, you're looking at a view right now of the penetration for the black iron going to the burner that's inside the box. As you can see, it's like I said, I cut these off with a chisel, the ears to these two blocks, the ends of these two blocks. It's a little oversized at the bottom because this is 1-inch black iron. They're also cut off all the way to the top of that first course. Reason being is that we need that air to get into the oven in order to keep the burner burning. So, that being said, let's go up and look through our second course. And you can see the space, obviously, where blocks come together at the end. This void right here has to be kept from being filled, so we don't fill that air chamber. So, on the first course before laying the second course, I would suggest highly that you block this out with a piece of tar paper, small piece of black metal, or tin, whatever it may be, to not allow mortar to go down in there, to allow that airspace to remain. Okay, now you can see the 4-course, 8-inch block masonry box complete. Again, you got to maintain a width of 48 inches, or a length of 48 inches inside by a width of 24 inches, and therefore that plate will fit in there and it'll bond out, meaning that you can use, like I said, you can use block. You can use block or you can use brick. Brick would come in 4 inches, approximately 3 3/4 inches right here, but your inside dimension would remain the same for this to work. Now I want to show you, there's the plate in there, right? Okay, now another thing I want to mention is that I highly recommend that all these masonry cells are filled solid with either concrete or mortar. This will help retain the heat and make it a much sturdier oven. Also, I can't emphasize enough that the top course has got to be completely level and has got to be flat. No bumps or humps, so the cover fits tightly. Now what we're going to show you is how we can lean up the metal plate and we can access the burner. Now what you're going to have to do is carefully light the burner. You don't want the burner on high. You want the burner on low so that you can lean in, get it lit from the opposite end, put the cover back on, or not the cover, I'm sorry, the burner plate back down, and then slowly increase the propane. Cut. Alright, we've tilted the metal burner plate up. Now here's the burner assembly, a simple propane tank with a regulator and a flow adjustment knob. The hose leads to the input into the burner assembly with air induction holes provided on the end cap so that there's enough air mixture with the fuel to allow the flame to burn in the burners. Again, that's for the flame, and that where I wallowed out those ears is to allow outside air to go in to keep the combustion going. Now, like any typical propane tank that I'm sure you're familiar with over there, it's simply like a faucet. To close the tank, it's turned clockwise as the rotation of a clock. Now what we're going to do, and then the red knob is the opposite of that. Clockwise turns it on, counterclockwise turns it off. We want to make sure the red knob is completely off, which means counterclockwise, off tight. We turn the tank on by opening it as a normal faucet. The tank is on. Now, this is a two-party situation here, to where we want one person here to slowly turn the red knob, again, clockwise to allow fuel out of the tank, just about a quarter turn. It'll allow enough gas to go to the burner to ignite by leaning in, off to the side. Do not let the gas run by yourself, and take your time to get over there and light the burner, or you will have a problem. It could flare up. 2 people, one on the tank, one with the lighter. Okay, Jose has turned on the tank all the way open as a faucet would turn on. Now the red knob, again, like I said, which is counterclockwise, or clockwise to turn it on. Clockwise to turn it on. He's turning on 1.5 turns. Oh. Off?
Yeah. There it goes.
Okay. Now it's not going to be that hard of a flame at 1.5 turns, and it takes a second to cross over to the second side of the burner and the other side of the T. The burner is now lit up. Before it gets too hot, Jose and I have to let the steel frame or the steel plate down quickly. 3.5 inches of space at each end. And there you have it. We have ignition. We have our plate in place, and that's all there is to it as far as igniting. Now, what we're going to do next is we're going to put our cover on, and then we're going to let this come up to heat. Now remember, here it's about 28 degrees right now in North Carolina. In Haiti, I know it's a lot warmer. It won't take hardly as long as it will here to get this box to heat up, but nevertheless it does have to be brought to temperature. And we're going to show you our cover assembly with a thermometer so that we can know what the temperature is inside roughly. It's not going to be really exact, but it'll be rough. And then we're going to set our bread pans in there and bake some bread. Okay, we got a solid lid for the top. This one is made out of cement backer board for tile, 1/2 inch thick. It already comes in a 3x5 piece. We've cut a 2.5, probably a 3-inch would be fine. Either one would work. Hole in the top in order to, to exhaust the hot air to keep the circulation going inside the oven. What we have to do and be careful to do is, because the only access to the oven is through the top, you don't want to lose all the heat real fast. So you're going to need 2 people to lean this top back, and then 1 person to quickly load the loaves onto the steel board. So we're about to do that now. All right, hold it, Jose. Place the loaves on the metal tray. You can put more in there. We only got 6, but you guys could put more in there. We ought to leave at least 2 inches between each bread pan for circulation. Okay, then like I said, quickly, we're going to shut this cover, quickly. And then we have concrete masonry units that are left over to put on diagonally at each corner. So all in all, together, if you build it out of 8-inch block, again, remember that the inside dimension is the important dimension. It'll bond out with any masonry without any cutting, except for the hole where the gas line comes in and the ventilation above it, as I pointed out earlier. So all in all, it takes 48 block, 4 to weight it down, 44 in the structure. Now what we got is come up here, Steve. A simple thermometer. Any thermometer, baking thermometer will work. We got this on a wire. We're going to lower it into this hole. Being careful to keep it just above the loaves of bread so we can monitor a good cooking temperature. Give me a brick. Then the wire or string, weight it with a brick, and let it go. Depending on the time of day, depending on the humidity, depending on the temperature, it's going to be an experimentation on your part to get the loaves to come out properly. Before we lifted this cover, the thermometer read at 350 degrees, which is a typical bread baking temperature. We're at 350 right now. Of course, we lost some heat by taking the cover off, but it'll come back quick with the propane. So we're going to let it go right now, and this is going to take experimentation with the amount of gas flow. Again, remember, the metal valve on the top of the tank opens counterclockwise. The actual release of the gas from the propane tank is the red knob, which is a clockwise rotation to open it up. We got this at about 2 full turns open, but of course it's 30 degrees here, even less in the wind. It's pretty cold here. So you may not need to have it that wide open, but it's going to take experimenting. When you first build it, you're going to drop the thermometer through the hole, and then you're going to let it, any oven thermometer will work.
Okay, to achieve a oven thermometer, this is one of the typical ones you get at the grocery store, and you hang it on the oven rack. and this is just dangling by a piece of wire, as you can see. And it's been running, what, Dave, about 350 degrees?
Yes, sir.
All right, so that was the technique we used today.
And we're not setting it in the bread. Okay. All right, now we're ready to lift off the cover and take the bread pans out. You don't have to worry about retaining heat at this point unless you go for another batch.
And that would mean take it off and get them out real quick.
Yeah, take them off, get them out quick, and then I'm gonna lift it towards you, Buford.
I'm just trying to see how far.
Let me go towards you and just lean it up, and then you lean it up on the edge of the block, and you can just hold it there. Nina's gonna come around here with the tray that's on the back of the truck. Buford's got that.
Man, and there was some 2-gallon loaves of bread that turned out to 5 gallons.
And there's your bread.
And so we got holes in the steel plate. Did they come that way, or was that?
They just came that way. We didn't think it was
what they
gonna
had.
Yeah, that much of an impact on it.
Tomorrow, could we cook a big batch of fried rice on there?
More than likely.
Have to get the wire brush out to it.
These bread separable?
Again, there's the bread. If you want to go back to cooking again, we would need to shut the cover, bring it back up to temperature. Since we lost a lot of temperature, opening this whole oven up. And that would mean by Buford putting that thermometer back in there, which is just hovering above the plate, but not in a loaf of bread now.
Okay, so what are we looking? We're dangling down about 10 or 12 inches.
Yeah, 10 or 12 inches. And then
And
it's ready.
What was your cooking plate? 16 inches.
16 inches. So you're about 6 inches or so off of the surface of the metal plate. And that's it. Just so you know, we had an oven spray, or in your case, you could just spread some butter or lard or any kind of fat or oil in the pan. And then once you drop your loaves in there, look how easy they come out.
You got an oil
And
flour.
right here is the bottom, which isn't burnt, so it cooked very consistently. The plate didn't get very hot because it's 16 inches above the burner, as we showed you outside. Whoa, that one's too hot for me to handle. Here's another one.
Flour?
And right there is consistent bottom. And we're gonna cut into them here. See what we got.
Cook so we get a serrated knife.
Ready?
Yep. Go.
Saw, don't push. And you,
Super fluffy. Now, of course, if you're going to make whole wheat bread, it's going to have to go longer, as it's more dense. But otherwise,
where's the butter? Where's the butter? Y'all be able to tell a little something about that, because down south, you have to have butter on your bread.
voila.
Eat up.